Hello everyone, my name is Christopher Jones and I'm a product manager in the Oracle Database Group. I look after language APIs such as a Python driver that I'm going to talk about today. So welcome to the Oracle CloudWorld session exploring the latest open source Python API for Oracle database applications. I hope you enjoy the session. We've got a very light agenda today, very simple. It was supposed to be a technical session. So after looking at what's new in the driver, I got to dive straight into code examples. So Oracle Database has drivers for a large number of languages. Don't show them all here. Traditionally have a big slide with lots of stacks and pillars, but I'm just showing the big four ecosystems, Python, Java, .NET, and the C language. As you can see, both Java and .NET have what we call thin drivers that talk directly to the database at the bottom using the Oracle Network Protocol. We also have thick drivers that use Oracle's main C API, the Oracle Call Interface, or OCI. They use that for connectivity to the database. It provides a lot of functionality for data transfers and efficiency and optimization and all sorts of wonderful technologies. Today, of course, we're talking about Python on the left. So the CX Oracle driver, some of you probably know, is only available as a thick driver, and it requires the additional installation of Oracle client libraries that contain OCI. Although we've improved downloads, such as by removing the click-through requirement, some users still find installation of those Oracle client or the instant client kind of painful. But to give a bit of background, the CX Oracle driver has had a long history. It was begun in 1998 for Oracle Database 8i and Python 1.5. In recent years, we hired the maintainer and creator, Anthony Tuaninga. He works for us now and has been doing stellar work with a small team here on the driver. And as a result of a long history, it's fully featured. It supports the Python Database API v2 specification and exposes many additional great Oracle features thanks to use of the Oracle client libraries. It is the most popular of our open source drivers. Gets about 3.5 million downloads a month, so it's a pretty significant share of our downloads in this space. Our team also looks after other drivers such as in the Node space, PHP space. We liaise with excellent community maintainers for the Ruby, Go drivers. But today, Python is the focus. With the popularity of the CX Oracle driver, you can imagine it's used in all sorts of applications, either directly or via popular frameworks, ORMs, and libraries. Used for small things, for data manipulation, gets used for big applications, a lot of data analysis. We see a lot of use in SQL Alchemy and Pandas, which of course uses SQL Alchemy underneath. So the great news is that the latest update of CX Oracle has new functionality and it has a new name. This is a major release with a significant new feature, a thin mode that talks directly to Oracle Database, just like the JDBC thin and .NET managed stacks I showed before. The Python Oracle DB thin mode makes installation easier, gives it tighter integration with the Python ecosystem. This provides better use of resources and gives it better performance. I'll show some figures later. An optional thick mode does use Oracle client libraries, making it the same as CX Oracle. I'll explain thin and thick later as we get through. But a quick sidebar comment about this release is that it's quite significant for Oracle. JDBC and .NET are binary releases, so they're closed source. The Python Oracle DB is the first open source implementation of Oracle Databases Network Protocol. So driver creators for other languages are able to make use of the reference we have published. I know there's some interest in people creating a Rust driver using a thin mode, and we ourselves are working on a Node.js, the Node.js JavaScript ecosystem, TypeScript ecosystem. We're working on a thin driver at the moment as well. I hope to bring that to you sometime soon. But the take-home points are that Python Oracle DB is just a standard upgrade from CX Oracle 8.3. It's really just a name change. Because it has a thin mode, the Oracle client libraries are not needed for most people. This lets you play with it on platforms such as, for example, Alpine Linux or on Apple Silicon M1, M2, and for Internet of Things devices. Easy installation is also great for some cloud deployments where installing and configuring client libraries perhaps isn't as easy as you might want. So applications can choose at runtime to use thin or thick mode. So you can install Oracle Client. And if you install the Oracle Client and run thick mode, then you get some additional functionality which matches CX Oracle. I'll go into details later. So one way to think about the upgrade is that we added a thin mode to CX Oracle and made this mode the default. So Python support is for the 3.x series. Obviously, as 3.11 is coming up, we'll start adding support for that. This matches the current CX Oracle releases, which also support only Python 3. Python 2, as you know, is out of date and not being maintained by the upstream community. It's still open source, using GitHub for its repository. License got updated. It used to be BSD-ish, and now we're using it because of Oracle's more common dual Apache and universal permissive licenses. It's still a binary module that gives us great performance, and lets install be relatively easy. And it still supports the Python API v2 specification, meaning frameworks and ORMs, etc. libraries can work in both thin and thick modes. And finishing up with a few quotes, users are very enthusiastic about it. You can see they liking the great performance for the thin mode and liking install functionality, in this case on the Apple M1 chip, where we don't have instant client libraries for various reasons. Because of the support for the Python DB API, frameworks and ORMs can make immediate use of the driver. Just a few lines of mapping code in the moment, just to map the new name back to CX Oracle. Those communities are busy updating for that new namespace. For example, SQL Alchemy, Pandas SQL Alchemy 2.0 branch has already merged native support for the namespace in the development branch. For Django, there's a pull request on GitHub for it. For Apache Airflow, native support has landed. We ourselves have released new packages on PyPy for macOS and Linux ARM chips, in addition to the previously available x86 Linux and Windows packages. So that makes installation a lot easier. And other platforms, the source code is available, so you can install that and build it yourself. Users of Conda Forge, kind of alternative SQL to PyPy, if you want to think of it that way. And luck, user has contributed the pull request to add support there, so you can install directly using that Forge. And Oracle Linux packages are in progress as I record this. So ecosystem's growing. Obviously had this big history with CX Oracle, and people are gradually moving across to the Python Oracle DB space. So installation, very simple, simple pip install, either downloads the binary package, which we make available, or downloads the source code and compiles. There is a dependency on Python's cryptography package in the thin mode, so that will get automatically installed, and make sure you keep that up to date. You want to make sure your security is top notch. Total size of this install is about 15 megabytes on macOS, and that gives you a fully functional driver immediately usable in applications. You can optionally install instant client libraries to be able to use thick mode. That's traditionally done with CX Oracle. The basic package on macOS is about 240, 242 megabytes. So thin mode has a definite size advantage, as you can see. Side note, I mean, although I, of course, recommend Oracle Linux, I used to work in the Oracle Linux group, I love it dearly, like what it does. I was actually playing with Alpine Linux Docker image the other day, and with a multi-stage Docker file, I was able to create a container of about 76 megabytes running Python 3.10 with Python Oracle DB installed. So that's pretty small if you want to go that way. Note that Alpine is not part of our test plan. I do definitely recommend and prefer using Oracle Linux. So let's look at atomic performance results on Linux to a remote 21C database. Thin mode is the dark blue column on the left. Units are in seconds, so lower is better. You can see that thin mode has an advantage for each of these data types being fetched. When looking at the CPU usage in the second graph, there are significant benefits to thin mode, letting you do more work on any given machine. You can see the actual percentage differences are quite big there for the varchar and the date in particular. Inserting data using execute many to upload in batches here, what's that, about 5 batches, so calling execute many 5 times. Thin mode still has an advantage, again, particularly reducing CPU usage, so you can do more on each machine. The thick mode times are roughly similar to CX Oracle results, but overall application load profile may be different between those two modes, depending on what it does. There is a refactored code base, and things like the Python global interpreter lock may have a different effect in CX Oracle versus Python Oracle DB thick mode. So do your own benchmarking before blindly upgrading critical systems. But as you saw from the quote before, performance has been quite good and well received, and yes, that person was seeing 60% benefit. So let's get into some of the features and talk about what thin and thick modes really are. What are the differences? Well, the thin mode feature set in our initial releases, we're up to 1.1 already, was focused on the database API, Python's API specification, and that lets the new driver version be used in frameworks. Other focus was on connection management, letting the driver be used with different database deployments, such as with RAC and Oracle Cloud. So looking at some of the planned downtime support, things like that in those environments. One design goal was to keep moving forward. So thin mode only supports connections to recentish database versions. As you know, 11.2s are kind of out the door. Adding support for the protocols for 11.2 is a non-trivial effort. So we're not planning on doing that. We really want you to keep moving forward. And if you want to connect to those old versions, you've still got the thick mode. I mean, you've been using CX Oracle with thick mode for some time, so there's no real difference there. I should point out some of the advanced functionality there, things like application continuity, the advanced queuing, continuous query notification, they're only available currently in thick mode. We know you all want all of those features to be available in thin mode, so you don't need Oracle Client installation, but adding those features is an ongoing project for us, bit by bit. The key points I want you to remember are that thin mode has more than enough functionality to be used for custom applications or with popular frameworks, ORMs in many, many environments, and that we're working on adding more functionality. This is a major release, and so there are some new features and other minor changes. I won't read the full laundry list here. While most of the effort was on implementing thin mode, there are various other improvements over CX Oracle 8.3. Most recent change in the last week or so has been the token authentication support, letting you use Oracle's identity access management systems or Azure Active Directory service for authentication to Oracle Autonomous Database. One nifty feature reading down the list is a new Oracle default object. Lets you set some attributes such as tuning parameters, and I want to call out that it has an attribute to determine whether lob data, long object data, is returned as a locator for streaming or inline as a string or bytes object. This means you don't need to create an output type handler to get the performance benefits of the direct data return. You may recall a lot of our examples, and Doc always said, create this type handler, things will work a lot better. Certainly for the smaller lobs where you're not streaming is beneficial. Now we just let you do that with a simple toggle. Unfortunately, the default is off for backward compatibility reasons, but I think you'll find it pretty handy and easy to set it on. The AQ team, Advanced Queuing team, has been making some welcome contributions, and so we have some new features available using recipient lists, message IDs, and recently passing JSON payloads. Remember, AQ is a thick mode feature at this stage. I should note in this release a few deprecated features no longer work, and continuing on the AQ theme, there was an old AQ API deprecated back in CX Oracle 7.2. So the new AQ API supported, but the old AQ API is not either in thick mode or thin mode. But many other previously deprecated features still work for the moment, giving you an upgrade path, which is relatively smooth. Remembering python-oracledb is just the upgrade from CX Oracle. In python-oracledb, we'll let a lot more attributes be set at runtime when you connect. We also have new classes, so you can encapsulate parameters. I'm certainly not going to read through that list. There are some subtleties about which mode these parameters apply to. I would love to have been able to make them apply equally both to thick and thin. It's just not possible with the plumbing at the moment in between the various layers down to the Oracle client libraries. So make sure you read the doc about what does and doesn't work in each mode, and make sure you're developing and testing in the same environment that you intend to deploy in. As you can see, this is all really connection related. Most of the runtime stuff just works unchanged between the versions. One final slide on new features is about the development experience. So as part of this release and the refactoring, there's a new Python top layer code to the driver. So we've been able to annotate this and let editors do smart completion, as shown here for the connect function. And there are other improvements landing even as I am recording this. So connection management, as I said, is perhaps the biggest change for applications. So I have a focus on that in this session. Once you are connected, then in applications, subject to the feature availability, they'll work the same in python-oracledb as they did in CX Oracle. And all our traditional recommendations about connection management and reducing round trips still apply. So previous CX Oracle presentations cover those topics. I'm not going to go over those in great detail here, but I'm sure you know the main points. So I'll just list them out for those who don't. use connection pools instead of standalone connections where possible to avoid connection setup and teardown costs. Obviously, if you had a single user application, that's not so important, but in multi-threaded applications, definitely want to be using a connection pool. Tune the array size attribute when fetching large data sets, so you can reduce the amount of time by fetching more data each round trip backwards and forwards between the database and Python. Similarly, if you know that you're fetching a small fixed number of rows, such as if you're paging data, then there's a prefetch attribute you can set to again, improve that buffering of data across the network. If you're inserting data, you saw before execute many being used in the performance benchmark. So use execute many when loading lots of data. Again, that reduces round trips. Don't commit unnecessarily. And I've mentioned lobs a couple of times, so fetch smaller lobs or medium lobs, whatever will fit in memory as strings or bytes instead of using the old default streaming API. So those are the common things. You might be interested in some of our Jupyter notebooks out there, which I have yet to update for python-oracledb, but they're out there for CX Oracle. And it's just the name has changed, so you should be able to access those and use those easily. They're on my GitHub page if you want to look later. So let's head into some examples looking at a connection first. So if you've got a code base and you want to quickly upgrade from CX Oracle, you can import the new driver and give it the old name as CX Oracle. Otherwise, just do a search and replace throughout your code, obviously changing CX Oracle to OracleDB. Note that connect and session pool function arguments must now be named parameters. So if they, you just use UN, PWCS, your connection strings, now you have to use the user equals UN syntax. This is a kind of requirement of the Python DB API, which we were not following before. We are now following, but this is perhaps the one gotcha there for anybody who's just dropping something in. Relatively simple, one-line code of change in your code. If you forget to do this, then you can end up with a slightly obscure error message, which is no thanks to the way the Python API was implemented. But it's annoying, but I'm sure you'll work out what you need to do. So you've got the new code base. Well, the driver is going to start in thin mode, so nothing actually needs to be done to use it. But of course, if you want that extra thick functionality, then you're going to need to call init Oracle client. And of course, separately install Oracle instant client libraries or use the client libraries available in your database. This call is the only way to enable thick mode. And once it is called, you can't go back to thin mode. So the driver has a sort of duality. It's either thick or it's either thin mode. And of course, if you're upgrading, if you want to try an existing app in thin mode, then you're going to need to remove any call you have to init Oracle client. In details on Mac OS for Intel chips, x86-64, you pass the libdir arguments set to the instant client directory. Similarly on Windows, you do the same. You can see I'm using the raw string there, R double quotes, because I've got the backslashes. I don't want the backslashes to be interpreted as escape characters. I should note that you don't want to pass a libdir parameter if your path environment variable already includes Oracle client libraries. You can use it, but I'd recommend against it because you might possibly end up with clashes if you have different versions being set inside the app versus outside the app. On Linux, you must always configure your environment library search path, such as LD library path, before you start Python. Pain point for me too, don't like that. It's just the way it is with some of the linking of third-party libraries in the Oracle client. So you don't pass a libdir argument, but you still need to call Oracle init, OracleDB init Oracle client to initialize that thick mode. And of course, if you don't call that function, you're just going to end up in thin mode with a usable driver without that extra functionality. There are some error message differences between thin and thick modes and to CX Oracle that you may want to keep in mind. These are documented in the manual. Here, I wanted to speak about a couple of scenarios. In our thin code, we've been able to improve some messages. For example, by giving more information like the actual service name in this connection failure and other messages, we might give the TNS names an ORA file path that was being used so you can actually know where to look to make changes. So this can help you diagnose problems faster. Unfortunately, we are making use of Python libraries for connectivity, and sometimes they don't give us enough information to be able to distinguish immediately what the problem is. So we have this generic error 6005, and this particular error just echoes the library error message, connection refused. And that number will vary from platform to platform. The cause in this case could be because the host doesn't actually have a database listener. So check for typos in the host and port used on your connect string. Or perhaps the firewall rejected the connection request. we'll continue to make improvements where we can, and as the Python libraries improve or change, then we'll follow those. Previously, I showed you there are lots of new connection arguments. We're trying to get away from external configuration files, certainly letting you do everything within the app or within the framework. So only thick mode reads SQLnet.ora files. Those files are where you can set some attributes for tracing. We commonly use it for that. Some of the encryption parameters and things like that. However, both modes read TNS names.ora files, so you can continue to use TNS aliases for your connection DSN parameters, which is definitely helpful with Autonomous Database, where you get a big long connection string and a TNS names.ora file. This example shows how thick mode and CX Oracle, of course, would disable out-of-band breaks at the network level. You'd have to have that external configuration file, SQLnet.ora, and set the flag disable out-of-band breaks on. In thin mode, there is no SQLnet.ora, so you pass the disable out-of-band breaks true, as you can see there at the bottom, at the connect time. Note that also you can pass the directory containing the TNS names.ora file at connection time as well. So you can actually, for different connect calls, pass different directory names. In thick mode, you have the one directory for the whole process. So this is my obligatory slide on connecting to Oracle Autonomous Database. I think every presentation has this if it's not purely on the cloud. In thick mode, the wallet for MTLS or mutual TLS, two-way TLS, whatever you want to call it, is configured in that external SQLnet.ora file. But this example on screen shows how thin mode needs a PEM file wallet configured, and you pass its location and password in the connect call itself. So those PEM files are included in recent ADBS wallets in the zip file, so you can re-download that. There's also a little script in our documentation if you've got one of the older files, and you can convert the .sso wallet into PEM format if you need to, just by running that script. Of course, having said this, it still looks complex, and both thin and thick mode support one-way TLS, or as it's known in the Cloud Console, just TLS, without any wallets whatsoever. And you just then need your credentials to connect and the correct connect string downloaded from the Cloud Console. So we've definitely made connections to Cloud easy, works in both thin and thick, obviously slightly different connection scenarios with different wallets needed by Oracle Client versus Python's mandate that it only works with PEM files. So one last connection example shows some changes and some best practices. Here I'm creating a pool of connections in the application, so we'd recommend this for multi-threaded applications or even perhaps applications which are idle for long periods of time, so you can release connections and let the pool handle things like planned down events and reconnection if the network drops when you do your next get connection. So as part of modernization, as you can see in the light blue, we have a new name. Although session pool still works, there's a preferred name as create pool. So session pool was a name that sort of was inherited from those Oracle client libraries. There is no client library in thin mode. People were searching for connection pool rather than session pool because of the terminology differences. So we've just taken this opportunity to do some modernization of the namespace. So session pool as a name is deprecated, as it'll be around forever and a day, but new code you can start using create pool. So either one creates a pool of connections in the application, and just to be different here, I'm passing the host, port, and service name as separate parameters instead of the single DSN connection string. And in fact, because of this, we've now deprecated the old make DSN function, which you might know. Our new syntax also lets you pass SIDs if you're still stuck in the dark ages and using SIDs instead of service name. But this is going to be easier going forward, and you can drop out that extra make DSN step. So one other change from CX Oracle is that the get mode default is now wait. So get mode is the behavior that an acquire when the app tries to get a connection from the pool has. And the wait mode means that if all pooled connections are currently used by the application, any further new acquire call will wait until a connection is freed back to the pool by another app user. This is a nicer behavior for most applications. It stops those users who want a new connection from getting an immediate error when they call acquire. And yes, they might wait momentarily, but the thesis is that the pool is going to be busy, going to be used, connections will be released relatively quickly, and some users will be able to continue Currently, that means currently the current default with no wait, or sorry, the old default with no wait, the CX Oracle default with no wait, means that those users calling acquire would immediately get an error, which isn't so useful. It doesn't give any resiliency to the application. This new default of wait just means that if you have a little load spike, then yeah, users might wait a while, but they're not going to get an error back. You can, of course, change the mode back if you don't like it. And lastly, in this particular example, I'm showing that I want to use database resident connection pooling, DRCP, some of you may be familiar with. And this is a kind of pooling on the database tier of the server processes that actually are doing all of the work for you. So this pooling means that those server processes can be shared across all sorts of applications, meaning that you have fewer processes on the database host, reducing memory pressure on that database host. In CX Oracle, you would have had to specify the server type in the connection string. Here, we now have the new attribute server type pooled. And setting a class is useful for just some partitioning of that pool. If you've got multiple applications using the same DRCP server-side pool. And the purity is whether or not we can reuse some of the memory there. Self means, yes, go for full reuse. Whatever's there, I'll take. And that gives higher scalability. Speaking about DRCP, look out for my colleague Sharad Chandran's session and technical brief about it. So one non-connection difference is in globalization. So the thin mode doesn't attempt to implement the national language support, the NLS libraries that is part of the Oracle client. So how do you get some localization when you query, for example, dates and you want, say, in this case, German date format? And the answer is to use Python's native functionality. So here is an example showing an output type handler set on the connection. So at the top two lines, just setting in Python space with locale, creating a locale date format to the format that the application wants. And the type handler maps any dates. If it sees a date, you can see DB type date. It maps any of those dates into that format using an out converter with a string format time. This example is, this changes all dates returned by select calls. And this particular example is usable in both thin and thick modes, which makes it easier if you want applications to be usable in any mode, either mode for any reason. So you don't necessarily need to use the NLS support in thick mode if you want to move to the Python support. I suspect some of you are already using something like this already. So my final example, as we're heading down in the home straight, is on using python-oracledb in frameworks, as I hinted before. Until native support for the new namespace is added to them, you can just simply drop this mapping code into your top-level file. The snippet's in our documentation, and I've written a couple of blog posts about using it, also using it in the SQL, and also about using the native support in the currently development SQL Alchemy 2.0 release. I've got a blog URL at the end of this talk. So we've tested SQL Alchemy, Pandas, and Django with this. I should acknowledge those test suites. They provided a great test bed for our thin mode changes and improved, for example, our SQL statement bind variable parsing code. And so we really do appreciate the work we've done there, and working with those communities has been fantastic. The SQL Alchemy 2.0 development line, by the way, also has a mode which lets you toggle whether you want to use thin or thick mode. So this is great. You don't need to add your own init Oracle client call. So the futures, what are the futures? Well, we want to add support for more features. Obviously, as new database features come in, we're going to be adding those. And we want to improve the compatibility between the parity between thin and thick modes. As a bigger project, we'd like to look at async IO support in Python. A lot of people have requested that. This is a big project, so I don't have any timeline or guarantee that it's going to occur. Please get involved on the forums, on the GitHub forums, the discussion list about that, because I'm sure there'll be some design changes that we need, or a whole new API for that. We're not adding anything new under the CX Oracle namespace. All of the new work's going to be on python-oracledb, but we're going to create some new binary packages for at least Python 3.11 when that is released, which will be good. Python 3.11 is supposed to have some new performance benefits, even if it doesn't actually get rid of the global interpreter lock yet. I'm sure you'll be able to take advantage of that for some bigger applications where perhaps you don't want to upgrade immediately to the new driver. And in summary, to wrap up finally, python-oracledb is just the new name for CX Oracle. It's a major release of CX Oracle, just like all other major releases you've upgraded to in the past. So, do your due diligence, do some testing, upgrade when you're ready. If you're starting new projects, obviously start with a new driver. Remains compatible with common frameworks and ORMs in both thin and thick modes. And the thin by default in the new driver gives a greatly improved deployment that is quick, lightweight to install. Environments without Oracle Client libraries can easily access Oracle Database, and this mode also has performance benefits. The optional thick mode supports additional database features for extended functionality, and will endeavor to implement similar features in thin mode. One great thing about this driver over the JDBC and .NET is that it's the same driver. You don't have to do a reinstall or anything major, just use the thick mode. Just add instant client libraries and set your path or call a net Oracle client appropriately. Python Oracle DB has an improved development experience, so you get more control over connections from within the application, and it gives a nicer IDE integration experience. So we're excited about the future of Python Oracle DB as it opens new possibilities for applications, and we hope you share that enthusiasm. So let me leave you with some resources. Thank you very much for watching this presentation on using Python with Oracle Database. Please contact me if you have any questions.